Good morning to everyone. My name is Malothu Kalyan. Today I am going to discuss about the topic is one dimension nanostructures. What are one dimension nanostructures? One dimension nanostructures represent a fascinating classes of material where two dimensions are confined to their nanoscale range of 1 to 100 nanometers. While one dimension extends a significantly longer, this unique geometry creates materials that behave fundamentally differently from their bulk counterparts. This structure include nanorods and nanowires, four materials shaped like tiny wires or rods with extraordinary directional properties. At this scale, quantum confinement effect dominate, leading to unique electrical, optical, and thermal behavior that simply do not exist in larger material. The confined electrons can only occupy specific energy levels, fundamentally alternating these materials conduct electricity, emits light, and interact with their environment. Nanowires and nanorods defining the differences. Will both nanowires and nanorods belongs to that family of one-dimensional nanostructure. They behave distinctive characteristics that make them situated for different application. Understanding these differences is crucial for selecting the right material for specific technological needs. Nanowires mean typical solid filament with diameter ranging from approximately 1 nanometer to 100 of nanometers. Their light can extend up to tens of micrometer or more, giving them extremely high aspect ratios. This extend structure exclusive in application requiring long range electrical conductivity or inter- interconnection. Interconnection. Nanorods, shorter rod shaped nano particles with careful controlled aspect ratios typically synthesized through colloidal chemistry method. Their more compact geometry makes them ideal for applications in easy solution-based processing, biological labeling, and optical device where precise, precise and size of control is a paramount. Here, the foundation and aspects their differences both serve as fundamental one-dimensional building blocks, and in nano technology, their unique geometries enable directional charge transports, isotropic properties, and quantum effect that are realization and fields from electronics to medicine. Quantum confinement and unique properties. When electrons are confined literally in nanoscale dimension, they can no longer move freely in all directions as they do in bulk material. That later confinement forces of electrons into discrete energy levels and creating a phenomenon known as quantum confinement. This result is a dramatic departure from the classical physics, and the quantum behavior is manifest in several remarkable ways. Electrical conductance becomes a quantized, meaning electrons can only flow in a specific amount there rather than continuously charged. Transport becomes highly anisotropic and flowing much more easily and along the length of the structure this than across it. Perhaps a most striking is the ability to twin optical emission by simply changing the diameter of the nanostructures. Nanoscale transistor quantum effect enabled to transistor smaller than ever before with switching speed and power efficiency untraceable with conventional silicon. Advanced photonics enable optic optical emission enable precision and control over a light and generation of for the next generation display and communications. Ultra sensitive and sensors. The high surface to volume ratio of quantum properties make these structures exploitationally sensitive to environmental changes. Energy device. Enhanced charge transport and surface reactivity improve solar cells, batteries, and catalysis for sustainable energy. Synthesize approaches, bottom up and top down. Creating one-dimensional nanostructures require precision at the atomic level. Scientists have developed two complementary strategies: bottom-up method that build a structure and atoms by atom and top-down approaches that curve nanostructure from larger material. Each approaches offers a distinct advantages for different applications and material. Bottom-up synthesis, building for small molecular procedures and using a vapor liquid solid solution liquid solid chemical vapor deposition and sol- solvothermal method. These techniques offers a exportational control over a composition and crystallinity. Top down fabrication, start, starting with bulk material and using a lithography focused in beam milling and reactive ion etching to create a nanostructure. This approach is exclusively and creating the preciously positioned structure with a excellent integrations into a existing device and architectures. SLS method spotlight. The solution liquid solid method represent an allied bottom up approach where nanoparticles are catalysis dissolved in solution and direct the growth of high quality semiconductor nanowise materials like CDSC, and CDTE can be growth with exportational control at a relatively low temperature, making this method of particularly attractive for large scale production and integrations with flexible structure. Cutting edge example of nanowires and nanorods. The diversity of the diversity of materials that can synthesize as one-dimensional nanostructure, remarkable spinning semiconductors and metals, and even biological molecules, and each materials or classes bring in unique properties and applications to the nanoscale revolution. Semiconductor nanowise materials like silicon, gallium nitride, and indium phosphide from the backbone of nanoscale electrons. These nanowires are enabled to ultra small transistors with exponential performance and highly sensitive to a photoconductor capable to detecting the signals, photons, and their band gaps can be preciously and turned to through a diameter control. Metallic nanowires, gold, platinum nanowires are serve a critical components of in nano interconnections and enabling to electrical connections at the scale of impossible with conventional lithography. Their plasmic and properties are fourth with collective oscillations of electrons and four makes the enabled for optical sensors and surface enhanced spectroscopy and next generation optical circuit. Molecular nanowires, DNA molecules and inorganic molecular chains represent the ultimate in minimization. These bio-inspired nanowires are enabled to revolutionary and applications in a bioelectronics serving as scaffold for a photon sensor. Templates for metallic in wires are growth and the chromogable assembles for buildings complex and nanostructures and from the bottom up. Characterization techniques. Understanding and controlling the properties of one-dimensional nanostructures require those sophisticated characterization tools and capable of probing a matters at the nanoscale. Modern microscopy, electrical measurement and spectroscopy techniques and reveal the atomic structures, electronic properties and quantum behavior of these tiny materials. Electronic microscopy, transmission electrons on microscopy and scanning electrons microscopy provide a direct visualization of nanostructure, nano nano morphology, revealing the diameter, length, and surface feature. High resolution TEM can image individual atomic columns, exposing crystal structure defect and interference critical to device performance. Electrical measurement. Nano wire field effect is transistor as both a device and characterization platforms. By applying a voltage and measuring current flow, researchers probe electrical conductivity, carrier mobility, and proton photo response. The measurements reveal how the quantum confinement affect a charge or transports at the nanoscale. Optical spectroscopy, phot- photoluminescence spectroscopy capture light emission from nanostructure, revealing the quantum confinement effects and material quality. Raman spectroscopy probe vibrational mode and identifying crystal phases and stress state. Together, these techniques provide a complete picture of optical and structural properties. Application of diverging the nano revolution. One dimension nanostructures are no longer confined to research laboratories. Fourth, they are actively and transferring multiple industries from that electronics in our device to that energy system powering our futures. And nanowires and nanorods are enabling breakthrough that seemed impossible just a year ago. Electronics. Ultra small transistor push more law and beyond are conventional limit and will nanowires are interconnections all over the challenge of connecting billions of components on a single chip and enhanced electrons mobility and reduced power composition make this structures essential for next generation computing. Biomedicine. Nanoscale sensor detects diseases by biomarks and with a unpredicted sensitivity, enabling to early and diagnosis and nanowise scaffold guide and tissues regenerations in a damaged organs will their biocompatibility and size make them an ideal from crucial in sensing and drug delivery in precision medicine and applications. Energy. Nanowise based solar cells and achieve the high efficiency through superior light and absorption and charge collection. Battery electrodes made from nanowires of increased capacity and faster charging. Platinum nanowires are catalyzes hydrogen production and for clean fuel and accelerating the renewable energy transition of optical electronics. LED and laser belt from semiconductor nanowires emits light with a tunable to wavelength controlled by quantum confinement. Photo detector achieves a single photon sensitivity from for quantum communication and advanced imaging. These properties enable to display with a perfect color and ultra secure communication network. Challenging and futures of display remarkable progress, significance, and upscale upscale remains before one dimension nanostructure can be fully realized. The transformative poten- potential bridges the gaps between laboratory demonstration and commercial manufacturing, requiring solving complex engineering challenges while maintaining the expectational properties that makes this material so promising. Assembly and integration, renewable large scale assembly and integrations into a functional device remains a critical hurdle, and current methods are struggle to position billions of nanowires with the precision required for a complex circuit, limiting and commercial adoption. Property control, achieving a construct a control over a size and composition and crystal space is essential for reproducible device performance. Small variation can dramatically alter electrical and optical properties, making quality control paramount. Emerging method, flow-based synthesis enabled continuous production with a better uniform, uniformly electrically controlled growth allows and real-time adjustment of structure properties, and hybrid nanostructures combining the multiple materials like unlock new functionalities must possible with signal component system. Vision for the futures, scalable and one-dimension nanostructures architecture will power next generation electronics with unprescribed speeds and efficiency will revolutionary energy systems and harvest and stores powers with a minimal environmental impact. The convergence of advanced synthesis, characterization, and assembly techniques is bringing this vision closer to relativity. Really. The promotion of 1D nano rods and nanowires. Quantum meets directions like combining to quantum confinement effect with a directional transports of creates a device of capabilities that simply connect exist in a conventional material. This unique combination of unlock performance levels of previously through impossible innovation across the industries, continued advances in a synthesis of precision and characterization techniques, and fuel of rapid innovation across electronics, energy, medicine, and beyond. Each breaking through in one field accelerates progress in other. Foundation technology, one dimension nanostructure from the foundation of the nanoscale revolution shaping our technological futures as manufacturing challenges are overcome. These materials are will becomes a obvious as a silicon is a today. The journey from the laboratory curious, curiosity to the transformative technology continues at an accelerating pace. Nanowires and nanorods are represented not just an incremental improvement but a fundamental remaining of how we build, device, harvest, and energy, and interact with the biology at the molecular level. The nanoscale revolution is her and one dimensional structure are leading the way.